All right. Good morning, good afternoon, good evening, folks, wherever you're tuning in from. This is on Dotnet Live. Welcome to 60 minutes of unscripted .NET entertainment, where our mission here is to empower the .NET community to achieve more. I'm your host, or one of them at least, Luis, and with me today are Cam and Scott.
Chiefs. Sorry, had to.
I know, right? Yeah. So if for any Eagles folks who we have in the chat, just it was a good game. It was very entertaining. But we're not going to talk about Super Bowl today. Here we have George, who's going to talk to us about Azure Functions and CosmosDB. But before we get started, George, do you want to introduce yourself?
Yeah, sure. Hello, everyone. Very happy to be here. Actually, I'm in Germany now, 6 o'clock in the afternoon, dark already. But the weather is getting better and better. I think we are slowly getting into the spring. So I live here for a few years now in Microsoft MVP for developer technologies. I organize the local .NET community, around 1,600 members. I work as a cloud DevOps and security. It's a role we call it as an umbrella term, platform engineering role for Slalom. And I think I'm enjoying every part of my life now because I also am a new dad. We have a newborn at home. So 3 months old now. So I'm finally free to go outside of home. Interesting life now, new things.
Awesome. Well, congratulations on your newborn. Very exciting. And for folks who may be familiar with this format, usually we do related bits, but in the interest of time, we started a bit late today. We're gonna skip that, and we're just gonna dive right in. And George, you can, whenever you're ready, sort of take it over and start talking to us here about Azure Functions and Cosmos DB.
Perfect. Thank you very much. So I did my introduction already. No need to spend much time here. So I can also move to the next slide, which is the company I work for. I will jump away from this. This is actually a talk that I did a couple of times in the past, although all of those times were in a workshop format, let's say, 3-4 hours. So I will try to speed up through some of the steps. If we had the time to do that, we'll do update bicep details on how to actually create your Azure Functional, Cosmos DB, your roles, everything. But now we'll try to focus on the important parts only. So first of all, we're gonna do that in .NET 6 isolated, which is the out-of-proc version. And I thought that it could be interesting enough to discuss a bit what that means, right? What's the difference between out-of-proc and in-proc? I would say that what we knew up until today was the in-process hosting. When we were saying I'm doing .NET 6, .NET 3, whatever in other functions, we're referring to the in-process hosting, which meant that the function, our code, the implementation, run in the same process as the Azure function runtime. Now, the difference when we are now is the out-of-process model, the .NET 6 isolated, as you might have seen, which means that our implementation runs in a separate process parallel to the Azure function runtime. What that change means, I have a slide here. These things I took from the Microsoft Docs, so you can find them for sure there. I bolded only the things that I consider quite important. So let's go quickly through them though. Supported .NET versions, only LTS versions for in process, all supported versions plus .NET Framework for the isolated because it's a different process, right? Binding extension, no, development packages, sorry, I jumped one, which is also I mark it as an important. I consider that to be a big change because it's a vast improvement. How you write it, how fast it is, everything. It's brand new. It's there since 2021, so it's battle tested. For me, that's a huge improvement. Binding extensions, nothing special. Model types, there is something that we lose there. The service SDK types, such as blob client, which is normal though, since it's a separate process, right? It's not the same anymore. HTTP trigger models, nothing important. Output binding interactions, nothing important there that I would say. Imperative bindings, not supported, but I mean, there is all anyway a recommendation for both models, applies both in process and out of process, to use directly the corresponding service SDKs and not actually do imperative bindings. By the way, imperative bindings is when we need to configure the parameters of a binding at runtime, right? Not at design time. So it seems it's not supported, but not a big loss because there was anyway a suggestion not to do that. Middlewares, that's a huge thing we have here. You will see that the code is slowly, it's closer to ASP.NET, what engineers outside of Azure Functions knew already. So they will find it very easy to jump into an Azure Function, into writing Azure Functions, because it is very similar from now on. Logging, nothing special. Application insights, nothing special. Cold start times, that is a thing because in one hand the process was there and we just had the normal just-in-time latency. Now we have that plus starting a new process, right? So we are going to have bigger cold start times. Now,
George, if I
yep.
could, I'll stop you there. I have a question on that previous slide. Let's assume I'm a viewer out there and I'm saying I want to use .NET 7 with a function. the way I'm reading this slide is the isolated worker model is the way to go if I want to use .NET 7. Is that correct?
Yeah, exactly. And that is exactly the next slide that I would show. So from .NET 6 on, which is also in LTS, we had isolated process, out of process available. We didn't have durable functions, and that's why some of us might fall back into in process. But from .NET 7 on, isolated process is the only way to go forward. We do have durable functions, and of course, in a few months, we'll be in an LTS version again. We will only support isolated process. Not we, Microsoft will only support isolated process. So it's done. There is no way back, right? It's the only way forward. What we were discussing earlier, what might lose by that and what we might gain, which for me, I think only taking under consideration the fact that a software engineer not related to Azure Functions can jump in so quickly to start writing and having had the decomposition and dependency injection, everything as it had it before, I think it's a huge improvement. Now, let's jump directly to see how we can create the C# function in one way and in the other way. We see that not much change. This is how you can do it from the CLI, and we'll also check the how we can do it from Visual Studio. Only the orange letters change. Nothing more. Of course, we need to, for the out-of-proc, to define the runtime, and we said that we have all supported frameworks, so we need to define the target framework. Everything else is exactly the same. Now, let me see, I took some notes on how we'll move faster than that. And now what we can do is, let's jump in quickly into Visual Studio. Let's see, where will it open? Here. Create a new project. Let's see how easy it is here. Azure Functions. Let's name that. We don't mind right now. We will create it. This is a difference here, right? .NET 7 isolated. There will be no .NET 7 in Pro, as we said, nothing more than that. But this is the difference. We just choose this and we're done, right? So instead of creating, just to speed up things, I have already created two Azure Functions. Let me open them and bring them here. Since I restarted, unfortunately, to manage to join. All my Visual Studios closed, but we are found it. Let's see what's the difference in the code. What is a sample project, a hello world with in process, and also let me open the out-of-proc.
While this is loading, George, quick question here from the chat. You mentioned many, the differences between in-proc and out-of-proc. Are there any changes to how long the functions can run for?
I'm not aware of any change there, to be honest. I'm not sure. I need to check that. I haven't checked that. You mean the timeout?
I believe so. Yes, that's the context of this question. How long can functions run for?
I think nothing changed there. If the friend that he's asking is mentioning there was a timeout, that it's there. Honestly, I have to check that. I don't know. Give me a second.
Yep, no worries.
And I will.
The thing I would add here, it's been a while since I've dug into this, but there are situations where if it's a very long running a job that you expect, functions may not be the best fit. Something like web jobs may be a better solution. Again, I'd have to look up the exact guidance there.
Yeah, of course, if it's long running, it's not advised to be an Azure function. Azure function should be closer to a nano service approach, small bursts of work, let's say. You can consider durable function, you can consider anything else. You can, though, if you go into premium or if you go into an app service plan, when you have your own VM and you run your function in your own isolated space, run it as long as you want. But if you are in consumption, then the timeout is standard and did not change, neither with the .NET 6 isolated, and I don't remember any plans changing with .NET 7, .NET 8 or anything. So I think no change there. We were here. So let's get to our solution explorer, and we see that actually from both of solutions, this is the in-proc and this is the out-of-process model. Only these changes. Sure, you might have the hosting or local settings. You can define them however you want, like the .NET isolated, you need to define that. But the actual difference is the program CS. And we'll see later in the more complete example, let's say, how having a program CS can help us inject our services in a way that it's very common, very usual for us, something that we always were doing in the ASP.NET environment. So this is the only change. And if we actually see the functions, then we'll see nothing changed, right? Sure, static and dependency injection here. If we could have dependency injection with .NET 6. Let me find it. I have it. I had all of these open. We could have, but not in a. We didn't have that native ASP.NET feeling. We had to decorate our assembly with the entry point, which assembly is the entry point, and then start doing our configuration and have everything that we had before. Now, this is the only way to run. And for me, having two ways of doing things, it means that whenever you are changing project, I work in a consultancy and we are seeing a lot of projects every day. Whenever you're changing project, you have to immediately change mindset and start thinking how that developer did it without dependency injection. How did he try to write maintainable code? And then next project, another thing, and then next another. So having only one way of doing things, it's massively, massively helpful. You don't see much difference here, are you? That's it. I would suggest, let's see now, that it's the best idea is to try to deploy. No, it's not. I deployed it already because it will be faster in the portal and Azure function, that we can see how easy it is to go there and get and try to deploy our dummy code here. One way is we get the publish profile, save it somewhere in our desktop, done, and then we come here. We want to deploy the isolated, because we come here, right click, publish. Do I have a publish profile already? I think I do, because I did that in the past, but we can create a new one if Studio allows. If not, then I will move forward to the next one. Workflow succeeded. Okay, there. You know what's the problem? I need to crash it. There is a pop-up window, a modal one, that I need to say. You have to select your publish profile settings, and it comes up somehow beside that when I have two screens. So right now, the only way, can I do that? No, the only way I can do that is to actually crash Visual Studio, shut it down. God, sorry for this. Visual Studio. Where is it? It's here. And this one, and this one. And then restart it. But this time bring it over to my other screen. And now, while you don't see, I right click publish. And let's see. And now I can click new, and that was the window, but I was coming on the other side. So import profile. Next, one thing we could do, and you could do that from the Visual Studio, is actually, since you have your Azure account connected, go and search your Azure function and see, I want to deploy there. Another thing is download your profile, and I did it that way because it's useful to do it from GitHub also. If we have time at the end, I doubt, we can see how you can set up GitHub to connect you with your Azure function and deploy it directly. So you can come here, browse. I saved it on my desktop. Next. Done. Right? Now I can bring that screen back and I can click, was it the last one? I can click publish. That's it. Nothing more to do. Now it will take a few seconds here. And when it does, we can actually come back here and see our Azure function running. This is the default screen. I found .NET Live free for some reason. But anyway, which is cool. Once it's done, I can also run so you can see how we get the proper URL. Publishing a few seconds more. So as the next step, once we are done more or less, let's say with an introduction into .NET SIG and Azure Functions, the interesting thing that we need to do now is connected with CosmosDB, right? Our function is deployed. What we will do next, because it will be deployed, but it will not run immediately. Let's see, first of all, if I run that locally, we'll see that we have the endpoints exposed by that function. Come here. This is it, /API, and then our function name, which is defined, that our root is defined as we always knew. So we can get that one here and come back to our portal, which we opened up our Azure function, put that here. I hope it was anonymous. And that is it. So it was that easy to run. Our Azure function is .NET isolated. Nothing changed, just a bit of code here and there, and we are done. Now, what's the goal at the end? Let me bring back my PowerPoint and come here. That is more or less what we need to do, right? We need to connect our Azure function with CosmosDB, but we don't want to do it with a key. This is one easy way to do it, but the keys, we have the need to rotate it. They are unsafe because you somehow might need to pass it on to someone else. The best way to do is with RBAC. Along with that, we will create an Azure Key Vault. This is a best practice to store all your keys anyways, and application insights. Now, when you try to deploy an Azure function from the portal, you will immediately get these parts, application insight. No, it will ask you, but anyway, you can get them automatically without an additional effort. Later on, we'll see how you do it with Bicep, and you will see that you need to set up all of them one by one, right? Now, I think you already know that creating an Azure function, you must create a general purpose Azure storage with it, for blobs, for queues, for table storage. This is because functions rely on Azure storage for operations such as managing triggers, logging function execution, so forth. So this storage comes with it. In Bicep or infrastructure as code, you need to deploy it separately. It doesn't come with the Azure function. Portal is a bit different. Now, one thing we can do, all of that thing, what I'm talking about, it exists in a repo that I need to open again. No, it's here. Let me bring that thing here. This thing, what we need to do is public on a repo that created some time ago. And we can do it in two ways. One way would be to explore all the Bicep, and the other way is to just click this button. If we have time, we'll see how from Bicep we create the Azure deploy JSON, and we can have this convenient. But for now, I just click that, and then we will return back to the CosmosDB. A few things about CosmosDB. We're choosing a group. Let's choose that one. blah, blah, blah. This is parameters we'll see later in Bicep. Let's leave them as are. You see that we are creating a database in CosmosDB named Life on Earth and a container in that database about humans. So this CosmosDB could contain every life, every possible life on Earth, and it will have containers for it, with the first container being our humans. So let's start creating that. And up until this is done, we will go back to our presentation. And I could have done that, but I didn't have time. Can go back to our presentation, where it's here, and move forward, not backward, and see a few things about CosmosDB. So, what is CosmosDB? It's a globally distributed multimodal database. We'll see the models later. It offers right from the start global distribution across any number of Azure regions, very low latency and very high throughput. Available APIs: PostgreSQL, MongoDB, Apache Cassandra and Gremlin, and Azure Table Storage. Why Azure Table Storage? Since we already have table storage, you can start small. You can start your small business with table storage, and once you are about to conquer the world, you switch to Azure Cosmos DB, right? Automatic and instant scalability, SLA-backed single-digit millisecond reads and writes, which is crazy, and 99.999 availability for the NoSQL data. It offers all of these things into 5 distinct models. Let me just check 1 second how we're still deploying in 5 distinct models. So I changed the order a bit of how you will find them in Azure's Cosmos DB, but first and second one are the two extremes, right? Strong consistency means that every read operation returns the most recent write, no matter how it is. You understand that the latency here is bigger. It provides a high level of consistency, of course, but the latencies are huge. Not huge, it's very fast, but it's the biggest of every available model. Eventual consistency means that when all writes stop, eventually all reads will be the same. So it's the loser, let's say, of all, the highest level of performance, but of course, the lowest level of consistency. And then we have the three levels in the middle, which are kind of balancing out the two extremes. Bounded staleness consistency. That means that the system guarantees, Azure Cosmos DB guarantees that read operations will return data that is no more than a specific, you need to specify that, number of versions behind, the stale versions. Right? The session consistency, which means that I'm writing, since I'm on the same session, my reads will be consistent. If I'm in another sessions, then my reads will not be consistent. And the last one is the consistent prefix consistency. I don't know if I should add consistency at the end, but anyway, this guarantees that you will get all the writes in a specific order. It doesn't guarantee that you will get them all together, like strong consistency, but it guarantees that you will get everything in the correct order. So it's something in the middle, all of these things, to cover all possible scenarios. I hope now that we are ready. Now, it's a function of that will happen pretty fast, I guess, hopefully. One thing I noticed when I was checking the example, that I'm using these that start with TMP are the ones that I deployed, and they're using the TMP, the name of the resource group, as a prefix. But you know what? That is wrong. There is a standardized way of doing that, and let me find it. I think it's define your naming convention. This one. Microsoft published this guide So we can all finally have a same way of naming our resources, and will convenient easier when we are jumping from system to system to actually understand immediately what those resources are. I didn't do it. Don't follow this. My advice on that one, just do whatever Microsoft suggests. Now let me see again. Did that complete it? Well, sorry for that. So DMP web app, yeah, everything is here. So what we have here is the infrastructure. If we'll see, we have our web app deployed, everything cool, and we have here our CosmosDB. If you go Data Explorer, it should have deployed also the database and all. Life on Earth database, and in here, humans container. No items, we'll create just a few, we'll see in a minute, but I think it will be much easier if we jump into the code now that actually does that requests. And let me open it up again. Now let me also close the previous two.
Thank you so much.
So let's function up. I will bring, oh no, it's here. So let me go here. That's the Solution Explorer. Let's see what we have here. Now, program CS, as we see from the hello world, from the sample included, and our HTTP triggers, right? I have two HTTP triggers here. One that it's I name it shelf HTTP triggers. One that's just a ping. Only thing it does is just it writes the datetime now. Last time it's called on the screen. And the other one is doing some kind of a health check in the CosmosDB. It's not any innovative work. You will see later what I'm doing here. I'm just checking if it's up and running. You can, of course, enrich it with your code. And the most important thing is our program CS, where we register all our services, and we have a nice looking way of organizing our code. Now, what do I do here? Besides those two, that they are not very important, we have our a few checks. If a Cosmos DB is defined, and if a Cosmos DB key is defined. Why I'm doing that? So if you want to do locally any work, you will not find easily a Cosmos DB emulator to do that thing, right? So what you need to do is maybe for a test environment or something, have access to a Cosmos DB, real Cosmos DB, and test what you want. For that thing, having access, RBAC will not work for you. You might want to have a key. Your administrator will provide you a key to play around. In order to do that, you can very well have that's the previous one, but it doesn't work. You can see it. You can copy it. You can have your local settings, which you do not deploy. It's on an ignore list on Git. It's not deployed. You can have it right here. And then if that thing exists, then you are connecting, you are registering your Life on Earth service, as we named our database, with a key. If not, you're just registering the endpoint. And what does that do? First of all, adding that line here means that it will try to read the local settings here, but once we are in Azure, it will actually read the configuration for Azure, right? The configuration of that, app settings. So we will have that hard-coded in the local settings here, but in Azure, let me bring back this one. If we go to our Azure function here, this one, configuration, takes a minute. We'll see that we also, our infrastructure as code, our biosep deployed the endpoint, but it didn't deploy a key. We could use the Azure Key Vault, but we said RBAC, blah, 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 better. It didn't deploy a key. So once our code is deployed in the Azure function, this part will run. When we are testing locally, this part is running. And what do we do here? Let's go here. We'll see that from the two, the only difference is this thing. For if you want to connect with a key, we are just passing the CosmosDB key, the actual key, in the Cosmos Client Builder. And if we want to connect without the key using RBAC, we just do that. So if I do this, it's RBAC. You need to have it. You need to set it up. But anyway, that is it. That's the only difference, right? So not much difference here. It's very, very easy for a software engineer to pass into that world, and it adds a huge benefit for the infrastructure to have everything without keys.
One thing I'd like to call out here for folks that see that default Azure credential, they may wonder, where does that come from? There's a Azure.identity NuGet package you can install, and this will provide all sorts of token-based credentials you can use to authenticate to Azure AD.
Yep.
George, can you help me check my understanding real quick? So I think what you're saying here is since RBAC authentication isn't available offline in development scenarios, you're saying, okay, so if you're using like the CosmosDB emulator or whatever, you'll use key-based authentication for those local development scenarios, but in the absence of a key up in the cloud, imperatively tells your code, hey, you're using RBAC authentication here.
Yep, exactly. So you can have both scenarios. If you want to run with a key for whatever reason, for a development environment, test environment, whatever, you can have that. For your production environment, you will not have that. And I understand that the code should be exactly the same. So in an ideal world, let me bring that back. In an ideal world, having our production and development environment, everything the same, we should have only one of those. For example, this thing. Sometimes, though, especially with the CosmosDB emulator, which you cannot find, actually, you cannot do the RBAC. I mean, it's the only way, right? In any case, I think this is mostly a demonstration approach than a real life, like a thing that you could actually try and do. Where was I now? Oh yeah, we did our dependency injections here. We checked the Azure Identity package, which it was here, and let's close that. And now let's see just a few things. CosmosDB service, nothing very special. We have the is healthy, which I'm just reading the account. Again, this is not production ready. This is just a sample. I'm just checking if it is deployed in at least one region, right? So then I assume it's healthy. You might want to invest more time here and write your own code if you want to reach so deep and actually check CosmosDB from your code. And then we have our human service, which does a query. Again, nothing special. It just uses here LINQ to do the query. You can use SQL-like syntax, which is very cool. It retrieves everything in the database. If you want to, again, a real-life scenario, you would need some pagination here, and they have a link here on how you could actually do that. For now, it just dumps everything. Names and stuff hard-coded, yeah, sure, all of that stuff. And it just deserialize what's in there to this very nice and not very special model. So based on that model, what we can do is go back to the CosmosDB. Where was it? TMP CosmosDB. And add some entries because you can very well deploy it later. So I think, was it location and name? Yeah, location and name. We can add Where was the new entry? A new item. Oh, no, I don't know why I didn't see that. I can delete that one and have name. Yeah, sorry. Name, George, location, Germany. That's one with what we have. Save it. Let's add the second one. Name. I don't know. Name Bob. Location. Come on. Location US. Save that too. Have these two entries in here. Let's try to deploy our application. Maybe I should have done that to spare some minutes, but this is how we can do it. We come to an action here, and once up until that deploys, we'll see how our bicep files are how I created the bicep file. So we have two actions here. The one is deploy .NET app. I'm here. I need to name the name of the resource group. That's the only thing. Now, this will deploy everything necessary. This will deploy actually our function app to the Azure function that we just created, and then we'll be able to query it. But up until that is done, we can visit our infrastructure. We can visit, first of all, let's see the repo a bit. App, different folder for all our code. This is like a monolithic repo, right? Mono repo. It contains both the infrastructure and our application code. Our application code, the one that we've seen already, and the infrastructure code. In here, what we see is the main bicep. We have a main bicep with references to module biceps. If we go into the main bicep, what we see first here is that all the parameters that we've seen while we were trying to deploy a few minutes ago our infrastructure, these have been set to a default value. It's up to you, of course, to do whatever you want, or to hide some of those parameters into variables, because you don't want to allow this kind of flexibility. Usually in a CI/CD, when you have also continuous deployment, you don't ask these questions, right? You have something established, you have the properties in a different file, and you read them from there. So, of course, this is just for demonstration. The order of things, although it's not important how they are in here, there is an order how you deploy things, and that makes sense. You can deploy RBAC before for the web app and the CosmosDB before you actually have the web app and the CosmosDB. And most of those dependencies, Bicep is able to find out on its own. Sometimes, though, you need to define them on your own. If you see that deployments happen in parallel, and of course, one doesn't exist. If we go back to the beginning here, we deploy the app in sites. I don't have time to invest much here, I think, but this is just the application insights you most probably know. We're deploying the Cosmos DB. We're deploying the Key Vault. We didn't speak about that, but let's see if we have time to see how we can have the keys of the storage there. We're deploying the storage, which is mandatory for our web app, and then we are deploying our web app. If you see here, parameters we are passing for the web app module includes, for example, the Cosmos DB endpoint. We need that. Includes the Key Vault secrets that we need to access our storage, application insights that we created up here, the Key Vault name, of course. So this stuff here, actually, from this stuff, Bicep can understand dependencies most of the time. Now, at the end, you will see that we are actually setting up our permissions. This is for the web app storage, and this is for Cosmos DB, our role-based access permissions. Cosmos DB, let's go to Cosmos DB here and see IAM and see role assignments. Oh, roles. These are the roles that CosmosDB has, the default roles, let's say, and we can choose any of those to assign to a user. But the problem is that these roles are administration roles, let's say, are roles that you can administrate CosmosDB, deploy it in new regions or whatever you want to do. If you're in a case that you have multiple databases in CosmosDB and you want to have one user access that database and one user access the other database, or if you want to have accounts that access only data and are not able to do any of this work defined here, then you need to have some custom roles. Now, let me go back here. No, I think I have it already did I? Is that one? Yeah. So these are the two built-in roles CosmosDB has that provides out of the box either data reader only or data contributor read and write for all the databases existing in our CosmosDB. I don't think I will have enough time to create custom roles, but it's relatively easy. Just copy that and you're done, right? We will use the data contributor role because we could also use the data reader role because that is the one that can give you us read and write. And this is actually what we are doing here. Where was that? Here. So what we are saying is that for the principal set in CosmosDB, that the principal ID of web app, the web app has the contributor role. That for what we are trying to do, the reader role would also be okay, but this is what we are doing, right? Nothing special. And if we see here, module CosmosDB RBAC, here, it's just a resource that we are calling, passing the role definition, which is the 000002, what we've seen, the principal ID, and the scope. So for this scope, that principal ID has that role. That's all the thing we've done. Let's go back and see if the app is deployed. So let's go to GitHub and to actions. Did we manage to? No, what happened now? Everything failed. What was not found? Oh, failed deploy. .NET 2 web app. But why web app? Was it web app the name? I don't even know. I don't even remember right now. It is web app. And why didn't TMP2? Oh my God. Did I write TMP2 or do I have it anywhere hard-coded now? I don't know right now, but let's quickly check our GitHub flows and we'll have an opportunity to see that. How much time do we have? 10 minutes. Should be enough. Build and deploy web app. And we are deploying. Do I have any TMP too hard-coded in here? Oh. Did I write TMP2? TMP. Okay. Let's hope this time we will succeed. Build in 2 minutes to fail. Yeah, could have happened faster. Anyway, I was saying that let's go back to our infrastructure as code. Here, oops, sorry. You know what? Let me check 1 minute. I don't want to have another failure because we will not have time to actually check it. Deploy web URL, blah, blah, blah. Web app name. And web app name is what? So it needs the entire user resource group name to end up with something like. So I will do another deploy because we don't have time now to try and debug it. And I will actually write that entire thing. Hopefully that will also work. Now we can go back to our code. One of the two will work, I mean. to our infrastructure. So we're seeing right at the end how we can set up CosmosDB to have the proper role for the principal, for the web app, but we can also dive into the web app here and check a few things about the web app, how we deploy web app. We said that already we need to have a storage before that. So we have a list of parameters, the CosmosDB endpoint, the application inside connection string, the analytics workspace, blah, 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 key vault. And what we are doing is we're creating our plan first. We then create the key vault role assignments. It's the exact same, exact same thing, right? If we need our web app to access the key vault. So what we are doing is saying that, you know what, for the key vault, for that resource, the principal ID web app needs to have this role. And you might be, you can use the roles as strings, the actual role, but I don't know. I prefer GUIDs because since they are globally unique, you can just do that, right? That is it. These are the Azure built-in roles. You can go here. I just added that as a key vault secrets user. I could use that, but I don't know. It's advised not to.
So George, I have a question for you.
Yeah.
You pointed out there's a log analytics workspace involved here. Is that required because of the workspace-based App Insights resource?
It is not required, but it's highly advised. Sorry, you said required because of what?
So with App Insights, you could do the classic mode or the workspace-based mode resource. And I'm just wondering if the log analytics workspace was required because of the type of App Insights resource it is.
You have a workspace that you can send all your logs, and on the App Insights will read that workspace and do whatever you want for the App Insights. So we need to have a workspace to actually hold as a storage, let's say, for our logs, right?
Got it.
Yeah. So we define our relationship with our key vault, so our web app is able to access our key vault. Let's also at the same time check what's happening here. Hope one of them will be successful. If not, I don't know. If not, you know what I can do? How much time do we have? We don't have enough time. Anyway.
We do have one question, George, and I believe
Yep.
you addressed this before. I'll put it up on the screen. The question is Azure storage necessary for Azure Functions? I believe you said yes, but I'll let you address that.
Yeah, definitely. If we go back to our diagram, let me bring this back all the way back here. We'll see that I think I've said that when we are deploying from the portal, we get that. But when we are deploying with infrastructure as code, no matter if it's Bicep, Terraform, whatever we need to define it on our own. Functions rely on the Azure storage for many operations. For example, logging, managing triggers, all of that stuff. You need to have an Azure function in Azure storage. It comes with it, right? So no way around it. Yeah, web app settings. Once we have our web app, again, it's kind of an order that we need to do things. We have our server farm, then we have our web app. We define, since we have a web app, and once it's ready, we define our relationship, and then we need to add some settings. Here is the settings that we're actually saying we want to run in .NET isolated, and it's before that it was that easy, just without that. It was the .NET in prog. Now we have that. We have our applications insights, our storage that can be used, and the CosmosDB endpoint that it will be read as an environment variable for our code. Now, if we didn't manage already, one thing we can do is come here. I don't know why. I will check that Probably it was expecting a TMP2 and I just deleted TMP.NET Live. Yeah, let's save that here. And let's come from here, function. Oops, I need to do that. I don't know, I have the same thing again. Publish. Is it okay? It's okay. New. Oh my God, it happened even with that, just because it's in that screen. What can you do? Now bring it over into that screen. Right click, publish. At any minute now, let's close that. I don't know why it's not closed anymore, but it's okay. It will pop up in the screen that you are seeing. And I will bring it over. Yep, here it is. We can deploy it next Azure function. I don't remember. Let's use the import file then. Finish, close, and this one over here, click publish. That should work. At least I should be able to publish with something. And it was Windows anyway. So I think that more or less concludes. It would be nice if it managed to deploy in time and see it, but even if it doesn't, what you will see, it's not very important. Just call a URL and we'll see either my name from Germany or Bob, I think it was, from the US. Are there any more questions or?
The only other question we got was, why is Azure storage necessary? But you already addressed that. You said it was for things like logging.
Yep, it is. It is. Azure storage is mandatory. App Insights and Key Vault is best practices, but of course you can deploy without them. Yeah.
Okay.
And the exact same process of using RBAC to access CosmosDB or the Key Vault can be done between any kind of processes in the in Azure, in services in Azure, right? It's nice to go actually keyless.
Yeah. And for clarity, it looked like you were using the NoSQL API in Cosmos. For folks that aren't aware, this is a newer name for what was previously known as the core API in Cosmos.
Yep. Is that the same thing that I've heard referred to as document DB?
That's a legacy name for Cosmos, yeah.
Okay.
Awesome.
So I think we had one endpoint named ping. Let's hope this will work. If not, I already know the error because I think I deployed, I think the app is, let me go here.
Well, while this is sort of loading, George, is there any sort of last words as we sort of try, wrap up this stream?
I mean, the good thing with Azure is that you can start low and your infrastructure and your cost can follow your success, right? This is the cloud benefit, but with using Azure table storage and starting from a simple storage and slowly migrating into CosmosDB or having your Azure functions in consumption and slowly moving ahead as your success is coming is actually the model to go forward, because you can, I mean, I'm running all these things and I pay almost nothing, right? This is, Microsoft gives me 130 euros and that's how much I spend doing presentations all month long, like 4 euros. So you can imagine that this is amazing for any business.
Awesome. That makes sense. And I don't know if you managed to sort of get this working, but while if you are able to, yeah, I see a 502 there.
Yeah, it's
all right.
because I was 64-bit.
It happens. Yeah. There's no demo that goes 100% every time, but yeah, we just wanted to thank you, George, for taking the time to kind of show us around and providing us with differences around different types of functions here. I want to thank folks for joining another session, right? Hopefully, you're going to go and try some of these things out. I think we pasted earlier in the chat the repo that George used to get this working for himself. And in addition to that, make sure to check out the other great .NET Live TV streams over at .NET/live. We got tons of them, including a back catalog of some of the on.NET Live shows that we've done before. We are not going to be here next week. It's a U.S. holiday, so we won't be streaming. However, the following week, which I believe is on the 27th, we're going to be back talking to Scott Arbit about Grace, which is basically a Git or a version control system written in F#. So if that's of interest to you, make sure to join us on the 27th. And yeah, we'll see you then. Thanks so much, everyone. Take care.
Bye.
Oh, everyone, thank you for having me.